Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So this video is for the final subsection for the topic for numerical method. So this section is about trapezoidal rule. Okay, what is about trapezoidal rule? Okay, trapezoidal rule is actually just a method to calculate the area under the graph, just like we did when we integrate a function. Okay, it's just the same thing to calculate area under the graph, but this is one of the method that can be used without involve any integration. Okay, so let's say we have a graph over here. Okay, so this will be the shape of the graph. Okay, so this graph will be started with A. Okay, let's say we mention right over here is A. So A will have a point on the graph. So this will be the y naught. So this is the y naught. So means this is the initial. And A also can be mentioned as x naught. Okay, it is the starting for our area in the graph. Okay, we start it from here, from x naught to y naught. Okay, so when we have x naught, then that means we have x1, x1, x2, x3, and so on. Okay, so let's say for right now we do it only until x3. So what we want to do over here is that we want to find the area under the graph from x0 until x3. So then x3 will also have a point on the graph. Same goes to x2, and also same goes to x1. Okay, so mean x1 will have y1, then for x2 have y2, and then for x3 is y3. Alright. Okay, the situation here is that the distance between x0 and x1, x2, and x3 is this. The distance within A to x1 and x1 to x2 and x2 to x3, it has the same length. So that length is denoted as h. Okay, so it has the same length and denoted as the h. Okay, h means h is the interval. Okay, length of the interval. And then meanwhile for x0, x1, x2, and x3, we call it as the ordinates. Okay, so here right now for this graph we have 3h, means that area has 3 interval, but for ordinates it has 4. So means ordinates will always have one value higher than the interval. Alright. Okay, so the ordinates is actually the value on the x-axis. Okay, the value on the x-axis. So in order to determine the value of x0, x1, x2, and x3, the formula is like this. x0 is, we start it with it is equal to a. So then x1 is equal to x0 plus h, and then x2 will be equal to x0 plus 2h, x3 will be equal to x0 plus 3h. So the formula is to determine the ordinates is that xn equal to x0 plus nh. Okay, so that is the that is about ordinates and interval. Alright. Okay, so right now, in order to find the area under the graph from x0 to x3, is that we need to consider each interval. Okay, let's look at focus on x0 to x1. So this is x0 and this is x1. It's the same graph, just we focus on x0 and x1. So this is x0. Okay, so within x0 and x1, what we can do from here is that we can form a trapezium from this shape. Okay, so in order to calculate the value of area under the graph from x0 to x1 is by calculating the area of the trapezium within the x0 and x1. So the area of the trapezium from x0 to x1, it will be based on the formula of the trapezium, 1 over 2. Then the width of the trapezium is the value of our interval, so that is h, and multiply with, okay, don't forget about the value of y0 and y1 on the y-axis. So that will be the length on two sides of the trapezium. So that will be y0 plus y1. So that is the area under the graph within x0 and x1. So in order for us to calculate the area under the graph from x0 until x3, so we need to calculate the trapezium for each interval. So then the formula goes by like this: xi ai equal to 1 over 2 h yi minus 1 plus yi. So where I is equal to 1, 2, 3 until n. Okay. Okay, so when we want to find our first interval, which is from x0 to x1, so our formula will be written as a1, mean the first area from x0 to x0 to x1, equal to 1 over 2 h y0 plus y1. So then for a2, which is the second interval from x1 to x2, so the formula will be 1 over 2 h y1 plus y2. Okay, so sum of the area of the trapezoid give us the approximate value of area under the curve. So then we can say that area under the curve is equal to sum area of trapezia. Okay, dipanggil trapezia sebab plural. Okay, so that's mean it is equal to a1 plus a2 plus a3 plus an, and that will be each of that. A1 is 1 over 2 h y0 plus y1 plus 1 over 2 h y1 plus y2 plus 1 over 2 h y2 plus y3 plus 1 over 2 h yn minus 1 plus yn. Okay, so this is the formula for sum of the trapezia, and then this equation can be simplified. So it will be h over 2 y0 plus y1 plus y1 plus y2 plus dot 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 plus yn minus 1 plus yn. Okay, so then by collecting the like term, so kita susunkan dia. So simplified, so area of the trapezia is equal to h over 2 of y naught plus 2 y1 plus y2 plus dot 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 plus yn minus 1 plus yn. So where h is equal to b minus a over n. Okay, I will explain about this later, but now let's focus on the formula of the area under the graph. So that is h over 2. So what you need to know that y naught is not multiplied by 2 and yn also is not multiplied by 2. So means the starting of the point is not multiplied by 2, the middle one is multiplied by 2, then the last one is not multiplied by 2. About h equal to b minus a, it is about the interval of the trapezoid. Okay, so let's say this is the same graph that I shown you before. This is y and x graph. So let's say we want to find the area between a and b. So in order to find the area between a and b, so the region of a and b need to be divided. Okay, this you already know, divided into several interval, or we call it into equal strips. Okay, kita bahagikan dia kepada equal strips. Sorry. Okay, so we want to find that. So in order to create h, what is h? H is the line in between this. So the x1, x2, x3 and x4. So this will be x0 and this will be x5. So this is the h. Okay, so the h can be calculated by h equal to b minus a over n. So n is based on the amount of strips that you want to use. So let's say this one has 1, 2, 3, 4 and 5. So for this one it has n equal to 5 strips. So from that you can find the value of h. So the number of strips basically depends on you, but usually mentioned in the question to use how many strips. Okay, let's first try an example. Find by trapezoidal rule for the value of integrate 50 exponent to the power of x dx, and then use 5 intervals and give your answer to 4 decimal place. Okay, so we are given an equation. So it mentioned here is to use 5 interval. So 5 intervals mean it has n 5 strips. So we can find the value of h. So h is equal to b minus a over n. So b is 5 minus 0 over 5 because it 1 in 5 interval. So then we have the value of h. So that is 1. So h is equal to 1. Okay. Next, based on we look at the equation of the area under the graph of trapezoidal rule. So the area is equal to h over 2 y naught plus 2 y1 plus y2 plus dot 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 plus yn minus 1 plus yn. Okay, so this is the value. This is the formula that we need to use. So next what we need to do is to find the value of this y0, y1, y2 and yn. Okay, so since we have 5 intervals, so 5 intervals equal to 6 ordinates. Okay, I explain it over here. So this will be x0, x1, x2, x3, x4 and finally x5. So there will be 5 intervals. So the interval is 1, 2, 3, 4 and 5. So we have 5 interval and 6 ordinates. So 6 ordinates of x0 will have equal number of y0, y1, y2, y3, y4 and y5. Also 6 number of y. So what we need to do next is to find the value of y. Okay. Okay, before we proceed for value of y, we have to find the value of the ordinates x0, x1, x2, x3, x4 and x5. So you can refer back the formula for ordinates means x0 is equal to a, x1 equal to a plus h, x2 a plus 2h, a plus 3h, a plus 5h, 4h sorry, 4h and a plus 5h. So from that we know that a is equal to 0 because our equation starts region is 5 and 0. So our a is 0. So then we have x0 is 0, x1 equal to 1, 2, 3, 4 and 5 because our h is equal to 1. We already find that at the early process of our solution. Okay, so then we have the number of ordinates. So then we find y0, y1, y2, y3, y4 and y5. So y0, it will be based on the equation of our function, that is exponent to the power of x. So this one will be exponent to the power of x0, exponent power x1, x2, exponent x3, exponent of x4 equal to exponent power of x5. So that is exponent power 0, exponent power 1, 2, 3, 4 and 5. So that is the value for our y0, y1, y2, y3, y4 and y5. Then we substitute the value into our equation, and that will be integration of 5, 0, exponent power of x dx is equal to 1 over 2, the formula 1 plus 2 exponent 1 plus exponent 2 plus exponent 3 plus exponent power of 4 plus exponent power of 5. Why does like over here is 1 is because exponent to the power of 0. Okay, so then you use your calculator to find the value of this, and then you will get your answer 159.4976 unit square. So that is the area under the graph for the region between 5 and 0 for graph of exponent to the power of x. Okay, let's look at our next example is to find and approximate value of integration 81 ln x dx, okay, using trapezoidal rule. So then siapa kita tulis dulu, using trapezoidal rule with 7 ordinates. Okay, give your answer to 4 decimal place. Okay, when the question mentioned here is to use 7 ordinates. Okay, so that's mean we have x0, x1, x2, x3, x4, x5 and x6. So when we have 7 ordinates, so this is 7 ordinates, 1 2 3 4 5 6 7. So that's mean we have 1 2 3 4 5 and 6 strips. So in order to find the value of h, so h will be equal to b minus a over n. So that is 8 minus 1 over 6. So that will be 7 over 6. So our length of the interval is 7 over 6 because of 7 ordinates have 6 strips. Okay, so then we have to find the value of the ordinates. So x0 equal to a, x1 equal to a plus h, x2 equal to a plus 2h, x3 equal to a plus 3h, x4 equal to a plus 4h, x5, and finally x6 equal to a plus 6h. Okay, so you can find the value that where a is equal to 1 as mentioned in the function. So x1 is equal to 1, then x0 is equal to 1 and x1 is 13 over 6. This is 10 over 3, 9 over 2, 17 over 3, 41 over 6, and finally it is equal to 8. So that is the value for ordinates. So then we find the value for y0, y1, y2, y3, y4, y5, y5 and y6. So that is ln x0, ln x1, ln x2, ln x3, ln x5, ln x6 and ln this is ln x4, x5 and ln x6. Okay, so that is equal to ln 1, that is equal to 0, and ln 13 over 6, ln 10 over 3, ln 9 over 2, ln 17 over 3, ln 41 over 6 and ln 8. Okay, then we substitute the value into the formula of our trapezoidal rule. So that is a equal to 7 over 6 over 2, 0 plus 2 ln 13 over 6 plus ln 10 over 3 plus ln 9 over 2 plus ln 17 over 3 plus ln 41 over 6 close bracket plus ln 8. Okay, then you can find that our value for answer is 9.5403 unit square. Okay. Okay, sometime not sometime lah, if you refer to your reference book, they show a method to use a table. Okay, a table to place all these values, so make better lah, looks more tidy. You can also use that. So I also want to encourage you to use the table. Okay, you can refer to your reference book how to use that kind of table. Okay, our final example is find area of 50 square root 1 plus x square, okay, dx, okay, by using trapezoidal rule with 6 ordinates. Okay, you have given 6 ordinates and give your answer in 3 decimal place. Okay, so firstly we find the value of h. So h equal to b minus a over n, so that 5 minus 0 over, so 6 ordinates mean we have 5 interval, so 5 minus 0 over 5, so h is equal to 1. Okay, now I want to show you how to use the table. Okay, buruk tu lah. Okay, so this is value for x, value for y. Alright, then for x we have x0, x1, x2, x3, x4, and one more thing, x5. Okay, tambah x1 kat bawah. Okay, then we can find that our value for x0 is equal to 0, equal to 1, equal to 2, equal to 3, equal to 4, equal to 5. Okay, for this one I just give a recap sikit. X equal to a plus n h. Okay, you can use this formula. Okay, for y, so means we substitute our value of x0 into our function, so that we have 1 for x0 is equal to 1, and then right here is square root of 2, square root of 5, square root of 10, square root of 17, and then square root of 26. Okay, why do we separate in these two different column? Okay, sebab on the right one will be multiplied by 2. Okay, you can refer to the formula, it will be multiplied by 2, and on the left one is not multiplied by 2. Okay, so from here you calculate the sum of this, so it will be 6.0990, and for right here is 10.9357. Okay, you can use your calculator by adding square root of 2, square root of 5, square root of 10, and square root of 17, then you will get 10.9357. Okay, so from here you can say integration of 50 square root of 1 plus x square dx. Okay, so it will be equal to 1 over 2 to 10.9357 and plus 6.0990, and then our answer is 13.9852. So question 1 in 3 decimal place, so 13.985 unit square. So that is our answer.